Hey guys, here's the spiral review for spiral 6. We're going to start with some absolute value, and for this I'm going to think about where my vertex is going to be. I know it's going to be whatever makes the inside of this 0, and if I were to make a table for this, I'd start with a point where x equals 3. When I plug that in, I get 0, and then 6 times 0 is still 0, plus 2 is going to be 2. Okay. I'm looking for some points on either side of this. I happen to notice that I've got a 1/6 in front. In fact, I have negative 1/6. I'm feeling a little bit on the lazy side. I don't want to graph fractional points. So I know if I can make this thing equal some kind of 6, either 6 or negative 6, my life's going to be a little bit easier. So what I'm going to try to do is figure out some values that'll make that happen. Okay. To make this 6, I've got to do 9 minus 3 is 6. So let's use the point 9. Okay? 9 minus 3 is 6. Absolute value is still 6. Times negative a sixth is negative 1. Plus 2 is going to be positive 1. Okay, that was useful for me because what I was able to do was find a value that gave me a nice number to work with. That's a really good strategy for us, to find numbers that make sense for us to work with. All right, if I want this to be negative 6 on the inside, so something minus 3 is negative 6, that number is going to be negative 3. I'd like you to also notice that these happen to be 6 above and 6 below 3. Okay? So we've got negative 3 minus 3 is negative 6. Absolute value is positive 6 times negative a sixth is negative 1, plus 2 is 1. Hey, that's symmetric. All right, so 3, 2, there's our vertex, 9, 1, and negative 3, 1. Does it make sense? That's a terrible, terrible line there. I'm going to actually undo that because I am so mortified by that. And I'm going to try to use, I'm using a contact case right now to see if I can do a better job with this, and that makes it worse. Okay, so there's going to be a V going through those points that I'm too embarrassed to do something with that actually works, because this, I'm going to write V there because that should be pointy, and obviously I can't do that today, so that's the best that I was able to do. I would like you to notice that we went down 1 and 6 to the right and down 1 and 6 to the left, and that happens to be the slope that we're looking at there. Second problem, we're looking at a piecewise function. First thing I'm going to do is set up my boundaries. So at positive 1, there's a boundary, and then at 4 is another boundary. Okay, and that takes care of that guy too. So we're looking at x plus 4, but only when x is less than 1. Okay, x plus 4, y-intercept of 4. We've got a slope of 1. And that guy is done. At the end, he's going to have an open circle because that is a less than. Second one, negative x plus 4. So I'm starting here, but my graph doesn't show up until I get to my boundary. Both sides of this are closed circles, and that would be a value for this. Okay, and finally x minus 4. Okay, I'll do this one in black. So we're starting at negative 4 and going up 1 and going up 1, and finally we get to the part where my graph shows up, and it happens to overlap with our second segment. Cool. So this is what our graph would look like. I'd like you to notice where the open and closed circles are. If an open and closed overlap, the closed fills in that open circle. And this is our final answer. Solving the absolute value. Well, this went so well last time that I'm really excited to do it again. First thing I'm going to try to do is get my absolute value thing by itself. And I have not done this one out, so I have no idea what to expect for an answer. So this could be fun. So I'm going to add 11 to both sides. And I've got 1/3 absolute value of 2x minus 3 is equal to 4/3 x plus 24. To get rid of the 1/3, I'm going to multiply both sides by 3. So you've got the absolute value of 2x minus 3 is equal to 4x plus 72. And from here, we're ready to look at the absolute value part of this. We know this is going to make two equations. The positive version, 2x minus 3 is equal to 4x plus 72. And the negative version, negative 2x minus 3 is equal to 4x plus 72. And when I begin to solve these things, I'm going to maybe subtract 2x from both sides and subtract 72 from both sides. Negative 75 is equal to 2x. X is equal to negative 75 over 2. Okay, on my other side, we end up with negative 2x plus 3 is equal to 4x plus 72. I'm going to add 2x to both sides. And I've got 6x, and I'm going to subtract 72 from both sides. And when I do that, I get 69, negative 69. Divide both sides by 6, and I get that x is equal to negative 69 over 6, which is the same as both those divisible by 3, negative 23 over 2. Okay, last step, I got to plug these both in to my equation up above and see what happens. So that is using this guy, because that's the simpler form. I'm going to zoom out a little bit, give me some room. So the absolute value of 2 times negative 75 over 2 minus 3. So that's going to be negative 75 minus 3, an absolute value, is equal to 4x plus 72. So you've got positive 78, and I probably should have plugged negative 75 in here, so 4 times negative 75 over 2. So that'll give us, 2 of those will cancel out, negative 150 plus 72. And that'll be negative 78, but not positive 78. So in looking at this, this appears to be an extraneous solution. So I'd write something like, this is, oops, I'm still in highlighter. This is extraneous. Looking at my other solution, I've got to plug this one in too. So I'm going to use the same version. So let's write the absolute value of 2 times negative 23 over 2 minus 3 is equal to 4 times negative 23 over 2 plus 72. I end up with negative 26 because those cancel out. Negative 23 minus 3 is negative 26. Absolute value makes the positive 26 is equal to 4. And then I've got this fractiony thing, so that cancels, leaving me with 2. Negative 46 plus 72 is going to be 26. This is an okay solution. This is not extraneous. Here I've got to graph a system of inequalities. I'm going to do these one at a time, and then shade the regions, okay? First up is x is less than or equal to negative 3. It's going to be a vertical line, solid because it's less than or equal, at negative 3. Second one, I've got 5x plus 3y is greater than or equal to negative 9. Because I know that 9 is divisible by 3, I'm going to turn this into slope-intercept form. So I've got 3y is greater than or equal to, and here we're going to have negative 5x minus 9. divide both sides by 3, and I get negative 5/3 x minus 3. Okay, this one is also a solid line, so I'm going to go down to negative 3. Negative 5/3 means down 5 over 3. 1, 2, 3, 4, 5. 1, 2, 3. I'll go backwards. 1, 2, 3, 4, 5. 1, 2, 3. And do a terrible job of that. Okay. And finally, I've got 2x minus y is less than or equal to 4. These numbers all come out pretty nice, so I'll just find some intercepts. If I plug in 0 for x, I end up getting negative y equals 4. In other words, 4 equals negative y. No, sorry, negative 4 equals positive y. Okay, and then if I plug in 0 for y, I get 2x equals 4. In other words, x has to be 2. So those are my intercepts. This is also solid. And I'd get something like this. All right, finding the shaded points. First off, I'm going to look at x is less than or equal to negative 3. And I'm just going to try some points first. So I'm going to try 0, 0. 0 is less than negative 3 is not true. Because that's not true, I'm going to color in the opposite side of my black line. So that's over here. Okay. Next up, I'm going to look at my second guy. I'm going to plug in the 0, 0 again. I get 0 is less than or equal to, greater than or equal to 0 minus 3, which is true. For that one, I'm going to color in this side of my red line. So that is this part up here. All right, and then finally, I've got my last guy. I'm going to do the same procedure. Start with 0, 0. And we've got 0 minus 0 is less than or equal to 4. And that is also true. So I'm going to color in that side of my blue line. And you might recognize that the only place that has all three colors is this little triangle up top. Here we've got a system of equations. I noticed that this is pretty well set up for elimination. If I multiply the bottom equation by 2, I end up with 2x minus 2y is equal to 26. Now looking at the top equation, 4x plus 2y is equal to 10. If I add these two equations together through linear combination, we get 6x, 0, and 36, dividing by 6x equals 6. Plugging this back in, we've got 6 minus y is equal to 13, and 24 plus 2y is equal to 10. The bottom one looks easier for me to solve. So if I minus 6 to both sides, I get negative y is equal to 7. Therefore, y is negative 7. If I check that in the top problem, so you get 24 plus negative 14 is 10, and that is true. My solution is 6 comma negative 7. We've got another system of equations. This one, things are not set up quite right for me. It might be useful to bring everything to the same side, because right now we have y's lined up, but then we have equals where we don't have some other stuff. So trying to set this up for elimination, you need to make sure everything is lined up together. To do that, I'm going to minus 6x to both sides. So we've got negative 16y minus 6x is equal to 22. I'm also going to divide this guy by 2 to see if that makes this any nicer. I don't really think it is, so maybe I'm going to stop that. Okay. I can either find a common multiple for 16 and 11 or 4 and 6. I think 4 and 6 is a better choice. So I'm going to multiply this guy. 4 and 6 have a common multiple of 12. If I multiply this one by 3 and this one by negative 2, I'm going to end up with negative 33y minus 12x is equal to 45. And 32y plus 12x is equal to negative 44. This actually looks like it's going to work out really nicely. When I add these together, I get negative y, 0, and 1, which means that y is equal to 1. Okay, let's plug this back in and see what happens. So we got negative 16 is equal to 22 plus 6x. And we've got negative 11 minus 4x is equal to 15. I'm going to check both of these to make sure my solution works. Negative 38 is equal to 6x, and I end up getting negative 38 over 6, which is negative 19 over 3. Okay? When I add 11 to both sides, I end up getting 26 is equal to negative 4x, and in dividing here, I get x is equal to negative 26 over 4, or negative 13 over 2. It might have been nice if I had noticed that negative y equals 1 means that y equals negative 1, because those obviously didn't come out to something that was worth getting as an answer, because they don't match. So this stuff is not correct work. So we got negative 11 times negative 1 minus 4x is equal to 15. That means 11 minus 4x is equal to 15. X is going to be negative 1 also, just to double check, because we've had a history in this problem of not getting the right thing. We get 16 is equal to 22 plus 6x minus 22 divided by 6, x equals negative 1. Whew. That was an easy fix. Here we've got to write the equation for a parabola. First thing I know is that the vertex is at 1, 4. Let's make my base vertex equation. Y equals a times the quantity x minus 1 squared plus 4. Something that I saw people forget a lot was the squared on this. That is a really important part. That's what defines the shape of this graph. I also saw people trying to use a slope to get the second point for a. You can't do that. Parabolas do not have a consistent slope that will let you do that. So instead we're going to plug that point in for y, for 3, and then for x. Okay? When I simplify things, so I've got 3. 3 minus 1 is 2. 2 squared is 4. So we've got 4 times a plus 4. Minus 4 to both sides, I get negative 1 is equal to 4a. A is equal to negative 1/4. Okay. The second issue people were having is that from this point you need to write an equation. So y equals negative 1/4 x minus 1 squared plus 4 is your final answer. For number 4, and I think this is the second number 4, I can identify my vertex, which is at 2, 4, and I can identify the value of the next point. So 2, 4, and then I went down 3, 1 to the right, down 3, 1 to the left for this. I need to make sure this has a curve, and this is not a pointy absolute value graph. And I have a parabola. Next up, we got some factoring. I decided to start out strong with a really delightful factoring problem, 7x squared minus 60x minus 27. First thing I'm going to do is multiply those two together, and I get negative 140 minus another 49 is going to be negative 189. Wow, that's awesome. I'm looking for things that multiply to negative 189 that also add up to negative 60. That's a 16. There we go. So I'm going to try to multiply that, add to that. It sounds like it's a lot of fun. I might do something like, I don't know, to multiply to negative 189. I know that's negative 1 times 189. 2 doesn't work. 3, negative 3 times 63. Hey, that's the opposite of what I need. How about 3 times negative 63? Bingo! 7x squared minus 63x plus 3x minus 27. Okay, those two have got a 7x in common. And I'm left with an x minus 9. And then I've got a 3 in common. I'm left with x minus 9. Now I've got an x minus 9 in common. So I've got x minus 9. And my leftovers for this are 7x and plus 3. Next up, we've got to do some more factoring. And here I'm going to start again by figuring out some good numbers to split my middle term up into. I'm going to multiply my a term and my c term, and I get negative 6x squared. And that's what I'm going to try to multiply to. Looking for numbers that multiply to negative 6x squared and also add up to plus 5x. That's my b term. Okay. I'm going to start negative 6, positive 1, and that goes to negative 5. But that's pretty close. So if I do 6 and negative 1, I get things that work. So 2x squared plus 6x minus 1x minus 3. Take a 2x out, and I'm left with an x plus 3. And take a minus 1 out, and I'm left with an x plus 3. Because I got the same number in both parentheses, I know that works. Now I've got an x plus 3 in both of these. I'm going to undistribute that. And I've got an x plus 3 and a 2x minus 1. Okay, looking pretty good. Let's check out the next one. Similarly, I'm going to start out by multiplying my a and c terms. 3 times negative 8 is going to be negative 24 x squared. Looking for things that multiply to negative 24x squared that also add up to 2x. Okay, negative 24, positive 1? No. How about negative 2, positive 12? Nope, that's 10. Negative 3, positive 8. That'll get me 5. Negative 4, positive 6. That'll get me 2. Okay, that's what I'm looking for. Nice. 3x squared minus 4x plus 6x minus 8. I can take an x out of that, and I've got 3x minus 4. And I can take a 2 out of these two, and I get 2 times 3x minus 4. I notice that I have two terms that have a 3x minus 4. I'm going to factor that out. And I'm left with an x plus 2. Those are my leftovers. Moving on, we're trying to now move from factoring to solving. So anytime that you have a quadratic set up like this, the first thing that we want to try is to factor it to see if it's factorable. So I'm going to do the same thing. A times c, negative 150 x squared. I'm looking for things that multiply to this and add up to negative 5x. I'm going to start with negative 150 and positive 1, way far off. Negative 75 and 2, still way too far off. Maybe negative 50 and 3, nope. 4 doesn't work, 5 does work, so 30 and 5, still too far off. 6 is going to be negative 25, and 6, no. 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 works, negative 15, and 10, oh, that works out to negative 5. I'm writing all these out so that I can make sure that we understand that this is not something that you need to be able to do in your head. You're welcome to have some kind of a strategy to keep on moving through these choices to get to some kind of a solution. So x squared minus 15x plus 10x minus 150. Factor the first part. X minus 15. Factor the second part, 10, and x minus 15. I have an x minus 15 in common. I'm going to pull that out front, so x minus 15, left with x plus 10. And that's equal to 0. To solve this problem, we're going to set each of these pieces equal to 0, because either x minus 15 is 0, which means that x is 15, or x plus 10 is equal to 0, which means that x is negative 10. These are our two solutions. 4x squared minus 16 is equal to 0. I'm going to try to solve this by factoring. I do have some other ways I can do this, but for the sake of getting us better at factoring things that look like this, I'm going to try that. There is a shortcut for this one. This is called the difference of two squares problem. But I want to show us that we can do this exactly the same way. But it might behoove you to write a plus 0x right in the middle there. That's a 0. Because now I'm looking for things that multiply, and 4 times negative 16 is going to be negative 64x squared, and also add up to 0. Pretty quickly you might realize that to add up to 0 you need two opposite numbers, and two opposite numbers that also multiply to 64 are going to be negative 8 and positive 8. All right. 4x squared minus 8x plus 8x minus 16 is equal to 0. We are going to have kind of a tricky thing here. And that's going to come in because if I start to factor this and pull too much out, there's a danger that I might accidentally factor half of this more than the other half and not get the same thing. So I'm going to start by trying to factor as much out as I can. So that'd be 4x out of the first two. And I'm left with x and a minus 2, not minus 8. And then if I factor an 8 out of the second set, I get x minus 2 also. Okay, that worked pretty well for us. First parenthesis is going to be 4x plus 8. Second parenthesis is going to be x minus 2. I get two equations. 4x plus 8 is equal to 0. Therefore, x is going to be negative 2. And x minus 2 is equal to 0. Therefore, x is 2. On a side note, if you take a look at this, 4x squared minus 16 is equal to 0. And you notice that both of these are factorable by 4. I could begin factoring as this. 4 times x squared minus 4 is equal to 0. You might even realize, if you know the difference of two squares factoring pattern, that x squared minus 4 could be written as x plus 2 and x minus 2. In other words, x plus 2 is equal to 0, x equals negative 2, and x minus 2 is equal to 0, or x is equal to 2. We're going to be factoring again. I'm going to do the same process, so I'm going to do 3x squared times negative 18. Looking for things that multiply to negative 54, x squared, and add up to negative 15. Okay, negative 54 times 1. No. Negative 27 times 2. Nope. Negative 18 times 3. Hey, that worked out really nicely because that's what we already kind of knew from the problem. Huh. All right, so negative 18 and 3 are our magic numbers. 3x squared minus 18x plus 3x minus 18 is equal to 0. I can take a 3x out of the beginning, and I'm left with x minus 6. And I can take a 3 out of the next part, and I'm left with x minus 6. I can factor out an x minus 6, and I've got x minus 6 times 3x plus 3 is equal to 0, which means that x minus 6 equals 0, x equals 6, and 3x plus 3 equals 0, which means that x is negative 1. Again, on a side note, I'd like you to notice that all three pieces of this are divisible by 3. If you wanted to make this a slightly simpler problem, you might begin by saying, okay, 3x squared minus 15x minus 18 is equal to 0. I know that one of the things I can do in algebra is to divide everything by the same number. And that's going to become x squared. Negative 15x divided by 3 is minus 5x. Negative 18 divided by 3 is minus 6. And 0 divided by 3 is 0. This is a much simpler problem for us to work with. When you try to find your values, this is going to really quickly come out to x minus 6 and x plus 1. And you don't have to deal with a lot of the stuff that you do if you start by multiplying. It's worth taking a minute or two to check to see if there are any ways to make the problems that we're working on a little bit simpler. Okay, 5x squared is equal to 9x. First thing I want to do is get everything onto the same side. In general, for quadratics, I need to have everything on the same side because most of the time I'm going to be doing some factoring. Factoring only works if you have 0 as an answer. The only way we can decide what values things have if we're multiplying is if the answer is 0, because then we know that one of them has to be 0. Okay, I don't have a third term here. I could do this by adding in a third term, and I'll show you how to do that in a minute. I'd like you to note that if I only have these two pieces, but they have some stuff in common already, both of these have an x, and I'd be left with 5x minus 9. So this is kind of straight undistributing. We haven't done this for a couple days. But here, that makes it so that I get to the answer really quickly. X equals 0. 5x minus 9 is equal to 0, which means x is 9/5. If that makes it a little bit painful for you, one of the things that we can do is treat this from this step as a quadratic with 3 terms. So 5x squared minus 9x plus 0 is equal to 0. Okay, now I'm going to do my a times c. 5x squared times 0, so 0x squared. And I'm trying to add up to negative 9x. Two things that multiply to 0 and add up to negative 9 are going to be negative 9 and 0. Those are acceptable. So we've got 5x squared minus 9x plus 0x plus 0. That's kind of weird, huh? Is equal to 0. Okay. At the beginning, I can take out an x, and I end up with 5x minus 9, and then all this other stuff is 0. So do we even need to include that in the problem? Oh, we just kind of accidentally did the same factoring we did over here, but here we used some scaffolding to get us there.